Hey, this is for Chapter 3 of the text, which is going to go over wind essentials and a little bit about ocean currents as well. So I'm going to switch over to share screen and we'll go through the PowerPoint. And I'm also going to point out the animations that you're going to need to watch that you can find on the module on the course homepage. Okay, so one of the things we're always concerned about when we talk about wind is why does the wind blow? And basically, what it is, it's just air moving from one region to another because of differences in air pressure, which, as we discussed in Chapter 2, that's caused by the uneven heating of the Earth's surface. Now, one thing that you need to understand about air pressure is it's the weight of the atmosphere pressing down onto the surface of the Earth. So it's the weight of all those molecules in the atmosphere pressing down onto the surface of the Earth. That's how we measure it. So when the molecules are closer together, meaning they're dense, they exert more force. When they are further apart, they would, of course, create less force because they're less dense. And here's how we measure this. Now, back in the old days, when they first discovered air pressure, they would put mercury into a dish. Then they would put a glass tube that was sealed on one end into the mercury. Now, what would happen is the weight of the air would press down on the liquid mercury, forcing it up the tube, and then they would have scaled measurements along the tube. And what they surmised, what they figured out was what normal sea level pressure was. And that would be, these are the two ways we usually describe it, in inches or millibars. So normal is 29.92 inches, meaning that the mercury went up the tube 29.92 inches at sea level. So that is normal. We can also express that as 1013.2 millibars of mercury. So that's usually the two ways that you'll see this discussed, like on the weather on the TV or the radio or something like that. There's also what we call the aneroid barometers, which are little, can be pocket things or even larger ones. You'll see them in homes by the beach a lot, and they will also give you the correct air pressure. So just highs and lows. So here's the normal, 1013 or 29.92 inches. So the US high, so it's going to be, remember, the denser the molecules, the more force they exert. And we usually see dense molecules in cold weather. So the US record high would be up in Alaska at 31.43. So compare that to the normal, or 1065, compare that to the normal. The low, again, is going to be usually in a tropical storm, which we'll discuss later on in the semester. But you have warm air rising up, so you have these kind of vacuums, if you will. So the air pressure is very low there, 26.2 versus 29. And then 882 versus 1013. So you have this very, very wide variation of air pressure. So if it's going above, if it's trending above 1013, that means the air pressure is increasing. If it's trending down, that means the air pressure is decreasing. This was usually going to mean stormy weather or rain. This is usually going to mean colder weather, clear skies, but cold weather. Okay, now wind is just the horizontal motion of the air caused by the differences in air pressure. So different parts of the earth and even different parts of very small areas, city blocks even, are going to have differences in air pressure. Okay, and so the wind, the motion of the air, is going to be created by the differences in that air pressure. And we can measure that okay, by wind vanes, or all, especially an anemometer, which I'll show you in the next slide. But the thing to remember is winds are always named for the direction from which they originate. So north winds come from the north, easterlies come from the east, westerlies come from the west, which we'll discuss in later semesters as well. I mean, later chapters as well. So just keep that in mind. Winds are always named for the directions from which they originate. Okay, now there's four forces that drive the wind. Gravity, what we call the pressure gradient force, the difference between air pressure on the Earth's surface, the Coriolis effect, which is kind of the spin of the Earth as it's rotating, and friction, because remember, the less air pressure or the less molecules in the air, the less dense the air, the less friction is going to be available. So those are the four forces that drive the wind. The pressure gradient force is the main one. It's just the difference in air pressure between 2 points on the Earth's surface. And that force causes the winds by driving the air from pressures of the high pressure to low pressure. So keep that in mind. It's most assuredly on the test, is that air always moves from high pressure to low pressure. If there's no difference in the air pressure, then there's no wind. The other thing to remember is cold, dense air exerts a greater pressure than warm, less dense air. When we map this, we use what we call an isobar, meaning that it connects points of equal lines of pressure. It's an isoline, iso meaning equal. So in this case, it's an isobar, meaning that any point that the line connects points of equal air pressure. And when you see this on a map, if the lines are very close together, spaced very close together, that means the wind is fast. If the lines are are farther apart, that means it's a slower wind speed. So that's kind of what it looks like. So here's a low pressure, here's the high. The winds are going to be moving from the high to the low. So notice the difference in air pressure, 1028, 996. As they move out of the high, they're being pulled into this low pressure because the air is rising up in the low, okay, and it's descending in the high. And so it moves from the high to the low. Notice here the differences in air pressure. The isolines are closer together, so that means that the wind speeds are going to be faster here than they are over here. And then if you take this and put it on the map of the United States, so here's your high pressure here, 1028, here's your low, 996, and the air is going to be moving from this high over to this low, pulled in by this low. So notice the isolines are very far apart here, so the winds are very, very light. But as they get closer to this low pressure, the isolines are closer and the wind speed picks up. So it's what we call a steep pressure gradient. So keep that in mind. Winds move high to low. Closer the isolines, the faster the wind speed. Okay, so we'll stop here and I'll pick this up in part 2.